Hey guys, welcome to your final math lesson of the year, an online assignment with the digits and vision. So, really glad to have had this opportunity to teach you guys. Now, while this will be our last new lesson, we will still have some activities and challenges that I'll have you complete over the next week or so. And I'll still be posting videos that I want you guys to watch and check those out. Participate in our class. Okay, this is the last official new lesson and content that we will be covering. So before we begin on that, I do want to give you guys your new 6th grade Mr. Sorrell's trivia today. And today's trivia question deals with pizza. So, simply put, I want you guys to guess what my favorite type of pizza was in 6th grade. I will let you know it's changed as of now. When I do eat pizza, it's quite different than what I ate in 6th grade. But I want you to guess what type of pizza that I ate, and then as a bonus, you guys can guess what my favorite pizza place was in 6th grade as well. I'll give you a hint for the pizza place. It is a place that's well known where I grew up in Cincinnati, but there's probably only like 2, maybe a little bit more locations in the greater Dayton area. So not so popular or well known up here, but very popular in Cincinnati. So you guys will answer what my favorite type of pizza was and what was my favorite pizza place. And then I want to know from you guys, what is your favorite type of pizza? So whatever you like, guys like cheese, pepperoni, anchovies on pizza, mac and cheese pizza. I don't know what combinations you guys like, but whatever you like, and then you can tell me what your favorite pizza place is as well. If you don't like pizza or you don't have a favorite pizza place, you can give me your favorite food or restaurant or whatever else you like. Okay? I want you guys to go ahead and answer those questions now. All right. So my favorite pizza in 6th grade was pepperoni pizza. Top notch. Would eat it like the frozen pizzas you can buy at the store, bagel bites, pizza rolls, pizza from that you could order from Pizza Place. A pepperoni pizza was where it was at for me. And then my favorite pizza place was a pizzeria called La Rosa's, which is a Cincinnati-based pizza company. They've kind of spread out a little bit here and there in Ohio, but not as well known as they are in Cincinnati. So a close second for me on that would probably would have been Donato's, growing up as well. Another good pizzeria place. 2 different type of pizzas, but both very, very good. So with that said, I look forward to reading your guys' answers to that later. So with our final new lesson, new content, it's going to be a bit of a review as well as some new content with finding area of polygons. So we're going to start with reviewing a bit with area of a trapezoid. Okay. Now recall that our formula for area of a trapezoid is A equals 1/2 multiplied by, in parentheses, base 1 plus base 2 multiplied by the height. Now I've simplified it here for you. I'm going to draw a little right angle here just to show that this is the height from base 1 to base 2. Okay. So we're going to go ahead and substitute in what we know. We have rewritten the formula we are going to use, and now we're going to substitute in and put it into place and use it. So we have area equals 1/2 multiply, and in parentheses, base 1. Recall, base 1 and base 2, we get from the trapezoid the two lines that are parallel to each other. Very, very important, those two lines that are parallel. So base 1, 12, plus base 2, 5. We're going to multiply that by the height. Recall, you find the height wherever that 90-degree angle is perpendicular to the bases. In this case, it would be 4 feet. I'm going to put the 4 right on there. Okay. Then we can go ahead and begin to calculate. Follow order of operations. Order of operations tells us to do groupings in parentheses first. So we'll add 12 plus 5 together. We'll get 17. And then multiply that by 4. Alright. As we've done before previously, you can grab your handy dandy calculator and we can practice entering this in. So we have 1/2. So we're going to enter in that 1, hit ABC, go ahead and hit 2. So 1/2. Then we're going to multiply by 17. If I can find it. So multiply by 17 and multiply by 4. Okay? When you do that, you will get 34 as your answer in your calculator. So we'll write 34 below. Recall we need to have our units when we're dealing with area. Our units for here are feet. And since it is area, it will be feet squared. Okay? So a little bit of review with the formula and how to use it. Alright guys, I want you on your own using that formula, A equals 1/2, and then in parentheses base 1 plus base 2 multiplied by height for this trapezoid. I want you guys to go ahead and see if you can evaluate for the area of this trapezoid. Do that now. Alright guys, so to find the area of this trapezoid, we're going to need to identify base 1, base 2, and the height. So let's start with base 1. Alright, base 1, we get the longer part of the bases, which in this case is measuring 12 feet, plus base 2, the shorter of the bases, up here it says 3 feet. In our height, we look for that perpendicular 90-degree angle that connects the two bases, and there's our height, 2 feet. Alright, now we can go ahead and use order of operations to solve. We would do groupings, which is 12 plus 3, so we have 1/2 multiplied by the sum of 12 plus 3, which is 15, multiplied by 2. Now this time I'm not going to enter into the calculator. Okay. When you do enter this in the calculator and you solve, you would get 15. Then you would need your units, which would be feet squared. Alright, let's keep on moving on, guys. I got one more here for you. I'm going to give you a little hint, okay, to find out what base 1 is. So recall base 1 is the total amount all the way across. You know that this is 4, this is 3, and this is 5. So you would actually have to write 5 feet down here. And you would need the total amount for the whole base with 4 plus 5 plus 3. So all of base 1, when you add that together, believe it or not, it's 12 feet. Alright, using the formula for area of a trapezoid, I want you guys to evaluate what the area of this trapezoid is going to be. Do that now. Okay, for this one, we use that formula A equals 1/2 multiplied by base 1 plus base 2 in parentheses multiplied by height. Base 1 and base 2, we just found out that base 1 is going to be 12 feet because you would have to add 4 plus 5 plus 3. And then base 2 is 5 feet in parentheses. and then we would multiply that by the height, which is 6 feet, and you get by using that perpendicular 90-degree angle. Okay? Then you can go ahead and solve using order of operations. You would do grouping 12 plus 5 first, get 17. You would bring down your half, multiply by 17, multiply by 6. When you enter this into the calculator, you will arrive at the answer of 51. You need your units, which in this case, since you're dealing with area, would be feet squared. Okay? Moving on, guys. Alright, so we're going to start looking at hexagons and octagons and figuring out the area of this or these. Okay? Now, these might look a little daunting, but all we're going to do is decompose these into triangles, and that's going to help us figure out what the area is. Okay? Notice, once again, here's that key marking here of the perpendicular 90-degree angle. This right here is showing you the height from one side of the hexagon to the what we call the midpoint or the middle of the hexagon. Okay, and that is 7 and 7,900 centimeters. Okay, this right here is showing you the length of each side of the hexagon. So this is 9, this would be 9, 9, 9, 9, and 9 all the way around. Okay, well, since we know that, since we know this is 9 and the distance from this side to the middle is 7,900 centimeters, we can draw a dotted line from the corner here, or what we would call a vertice, okay, a vertex, and this vertex also to the midpoint. Do you guys notice what shape we have drawn here? Okay, well, the polygon we've made is actually a triangle. Okay, and you can do this for the entire hexagon. Okay, notice how I'm going from the midpoint to each vertice here. Okay, and look at how many triangles we've made. We've made 6 triangles, which is also the number of sides there are in a hexagon. Look at that. So, keep in mind the number of triangles that you make in a hexagon is the number of triangles you make in a polygon will be the same number of sides that there are. So since you know this, you can figure out what the area of one of the triangles are and then multiply it by 6. So the formula for hexagon is the same as the formula for a triangle. Area equals half multiplied by base multiplied by height. But then, since it's a hexagon and has 6 sides, we're going to multiply that by 6. Okay? So let's figure this out. So we have area equals 1/2 multiplied by the base. The base in this case is 9. Okay, that's going to be the side of one of the hexagons. One side of the hexagon. The height is the distance from the side to the middle, which is 7 and 7/900. And we're going to multiply that area of that triangle by 6, since there's 6 total triangles there. Okay. We can then take our calculator and type all of this into it. So I'm going to show you guys. So we have 1 ABC 2. So there's our half. Multiplied by 9. Multiplied by 7 and 7/900. Multiplied by 6. When we have that, we can hit enter. We get 210 and 33 hundredths. So 210 and 33 hundredths. We still need our units since we're dealing with area, which would be centimeters. And since it's area, it would be squared. So that's how you find the area of a hexagon. Okay, we're going to move on to finding the area of an octagon. Okay, actually, we're going to do this in the next video. So at this point, go ahead and click on to part 2 of this video now.